factorize by the AC method. It's a quadratic expression. You could see the x squared and the x. So it's in a quadratic format. So we're going to list our A, our B, and our C. If you don't remember, A is the coefficient of the square of x, so it is going to be positive 3. B is actually the coefficient of the x, and it is actually 11. And C is our constant. It's just a number that is not attached to any letter. Now, this is called the AC method because we are going to multiply A times C. So if we multiply A times C, we're going to get 3 times 6, and this is going to give us 18. We need two numbers, okay, that are factors of 18, such that if you multiply them, it's going to give you 18. So if you multiply them, you will get 18. But if you should add them, you will get the B term, which is 11. So right there and about, we're thinking of 2 and 9. Okay, so 9 times 2 is 18. 9 plus 2 is 11. If you're wondering where we got that from, you could take this trick. You could list all the factor pairs of 18. For example, 18 times 1 gives 18. 9 times 2 gives 18. 6 times 3 gives 18. If you look at the factor pairs of 18, then one of those pair will always satisfy this dual combination that we need to work out in order to move on. So you would have realized that it is actually 9 and 2 that could give 11 and 18. Now, let's take a look at where else we're going to go now. Now, because my AC is actually a positive number, it simply means that I could either have two negatives that multiply, or it could be two positives that multiply. The result that I'm going to use will depending on what sign B has. So you could see that my B value was a positive. So because it's a positive, I'm going to have to take the positive response to use. Let's take a trip. So what are we going to do with positive 9 and positive 2? We're going to attach the variable x to them, and they will be used to replace 11x in the middle. So let us rewrite this. So we do have 3x squared. Now I'm going to put positive 9x. I'm going to put positive 2x plus 6. Basically, what we're doing with this method is that we're finding two terms that will actually turn the idea into 4. So we started off with 3, but when we interject our 2 terms here, we end up with 4 terms, which means that we're going to factorize now by grouping. So let us group our terms. So this is my group 1, and this is my group 2. Now, if you're asking, how are you going to know if you should put the 9 first or the 2 first? It does not matter, right? So if you had put 2x here plus the 9x after, it still will work itself out. And that is the beauty of choosing the right things. All right, let's go. So for group 1, what is common here? We have 3 and x, okay? We're going to divide everything in group 1 by 3x. Open a bracket. So when 3x is divided into 3x squared, then we're left with x. When 3x is divided into 9x, we're left with 3. So we do have x plus 3 in the bracket. We're going to bear in mind that the second bracket that is coming, we must have x plus 3 in it. But let us look. What is common here? The common factor here is actually 2. Do I make my 2 negative, or do I let it be positive? Well, it has to be positive so that when I divide it throughout, for example, when 2x is divided by 2, then we have x, and when 6 is divided by 2, we have 3. So you could see the exact bracket comes back. Whatever we had in our first bracket here, we're definitely seeing it in our second bracket, which means that we're okay. The common factor we do have is x plus 3, so we're going to take it out. And remember, All we have to do is to open a new parentheses, and then these will come here, and this will come here. So basically, we're done again. All right. Let us take a look at our sixth problem. All right. So question 6. All right. So for question 6, what we do have here is we do have 2x squared minus 6x plus 4. Again, there is, if you take a look at this, you're noticing that there is something in common. So I'm going to have to take it out. So I have 2 that is in common. So I'm going to take this out. So if I'm going to divide that 2 throughout to break this down, so I'm going to have x squared minus 6, my bad, minus 3x, and then a plus 2. Okay. So we have that. So sometimes you realize that you have to factor out what's common and then you move. Now we're going to focus on x squared minus 3x plus 2. And we're going to try to factorize this by the AC method. So let us take out what is A. It's 1, because this is a 1 here. And then what is B? It's negative 3. And what is C? That is 2. Now let us write AC. It really means that A must be multiplied by 2. So by C. So 1 times, so A must be multiplied by C. So 1 times 2 is 2. The factor pairs are just 2 and 1. Remember, when AC is positive, like in this case, it's either a negative 2 times a negative 1 or a positive 2 times a positive 1. Now, in this case, you're seeing that my B value is negative. Because my B value is negative, it is telling me that I have to use the ones with negatives. For example, negative 2 times negative 1 will give me positive 2. Negative 2 plus negative 1 will give me negative 3. So this is my AC and this is my B. So you could see that it was satisfied. So let us now go back and replace that negative 3 with these. Let's go. Remember though that this 2 is all the way out front, right? So in this bracket, and let me write a bigger bracket so that we could see what's going on. So what we have inside of this now is that we have x squared minus 2x minus 1x, which is just x, plus 2. Okay, so we have this inside. This 2 is still on the outside. So let us see what we have coming down. Now, I'm going to group these inside here because we do have 4 terms. So this is group 1 and this is group 2. Right? For group 1, it's going to be x. That is going to be my common factor. So I'm going to divide this by x. I'm going to divide that by x. So when x is divided into x squared, I'm left with x. But when x is divided into negative 2x, I'm left with negative 2. Already, I'm seeing x and 2. So what I'm going to have to use for this is that I'm going to have to use 1 because I need to get back an x and a 2. But I'm going to have to make it negative 1 so that when I divide this negative 1 here, I'll get positive x. And I'm going to divide this by negative 1 as well, such that the 2 divided by negative 1 will give me negative 2. Why am I making that effort? Because my first bracket, because as you can see, in my first bracket, I had x minus 2. I also needed to have x minus 2 in my second bracket. So let us finalize this now. What we do have is 2 over there. The common factor here is x minus 2. I could now isolate it there. And then this x will come in the other bracket, as we have been saying, and this negative 1 will come here. So basically, that's it for that problem there. The response is actually 2 times x minus 2 times x minus 1. And we're actually done with that. Let us take a trip to the seventh problem here. What we're doing here, we're trying to wrap up factorization in a nutshell. All right. So our seventh problem is actually 4q squared minus 5q minus 6. Again, there is nothing common throughout. So I'm going to actually use the AC method because it is quadratic. As you can see, the square is on that. Now, let's take a look here. What is A? A is 4. What is B? It's minus 5. Because remember, A is the coefficient of the square of Q, and B is the coefficient of Q, which is negative 5. C is actually negative 6. Let's find AC, which means 4 will be multiplied by 6. This will give us negative 24. Remember the deal. We need two things to multiply to give us back negative 24. But when we add those same things, it will give us back the middle term, which is negative 5. Now, this is actually an 8 and a 3, right? So let us think this out. For some persons who will struggle to find it, you could list your factor pairs of 24, 24 times 1, 12 times 2, 8 times 3, 6 times 4. All right. So these are basically our factor pairs that will be multiplied to give us 24. 24 times 1, 12 times 2, 8 times 3, 6 times 4. So here it is that this one is the only one that could give us a 5, and that is what you think of. Which one could give a 5? And because all of those will give 24 by multiplying. So here is the deal. Let's isolate our 8 and our 3. Whenever my AC is actually a negative number, like in this case, then one of the numbers will be negative and one will be positive. We normally say to you, let the bigger one take any sign B has. Now, B is a negative number here, which means that the 8 will be negative and the 3 will be positive. Now, we're going to attach the variable q to this, and it's going to replace the negative 5q. So let's come to our left side here. So we have 4q squared. Then I'm going to write negative 8 with a q, positive 3 with a q, minus 6. As you could see, I now have 4 terms. Because I have 4 terms, then I can factorize by grouping. So I'm going to group them. The first one, I'm going to call that group 1, and then I'm going to call this group 2. So for group 1, what is my greatest or my highest common factor? It's going to be 4q. So I'm going to divide group 1 by 4q. So let us carry this out. When 4q goes into itself, it's 1, but 4q goes into 4q to the second, then q will come down. When negative 8q is divided by 4q, we're just going to get a 2. So this is negative 2 here. Now let's take a look. Positive 3 will be my common factor for 3q minus 6. So I'm going to divide group 2 by positive 3. Positive 3 into itself, we're left with our q. Negative 6 divided by 3, we're left with 2. As you could see, my brackets come back. Q minus 2. So let us just write this back and then open a bracket. This comes here, that's 4q, and this one comes here, that's plus 3, and we're done. All right, let's look on our 8th example. What we're doing in this series is that we're trying to do all the ways in which your factorization can be presented to you. Let's look at our 8th example. So what we have here is a 6x squared plus 13x minus 5. Again, there is nothing that is common throughout, so we're going to have to factorize this by the AC method because we're seeing an x squared and the x, so we know it's a quadratic expression that we're looking at. Now, what we're going to do is we're going to have a, which is equal to 6, B, which is equal to 13, and C, which is equal to negative 5. Let's find AC. So AC is that we're going to take 6 and we're going to multiply this by negative 5. And what we're looking at here is negative 30. Now, again, the principle is we need two numbers that multiply to give negative 30. That's my AC. But these same two numbers will be added to give my B value, which is 13. Now, what we're going to do is those numbers are 15 and 2. But if you don't know, we're going to list the factor pairs of 30 and then we choose. So factor pairs of 30, things that multiply to give you back your 30 could be 30 and 1. You could be 15 and a 2. You're talking about 10 and a 3, and actually a 6 and a 5. These are all the possible pairs, what we call factor pairs of 30. Which one of these could give a 13? So you might be saying, okay, this could give a 13 and this could give 13. You're right. Now, the thing is, it's only one that can work. So let's bear in mind the context of the question here. The context here is that negative 30 is what we're looking at. So my AC is negative. So when my AC is negative, one of my numbers will be negative and one will be positive. When we think about that, it can't be this, because if any one of those numbers are negative, we're going to have a 7. So it has to be 15 and 2. So here is the deal. We have 15 and we have 2. Now, what are we going to do? Which one will be negative? Which one will be positive? Well, let's take a look at what my B value is. My B value was a positive 13. That means the largest number must be positive. So the 15 will be positive, the 2 will be negative. So that's what we're dealing with here. So the moment you realize your positives and your negatives, then we're going to take them. So we're going to take these, yeah? We're going to attach the variable x to it. We're going to put it where the middle term is, because now we want to turn it into 4 terms so that we can actually group them. Let us clear this up. So we have 6x squared plus 15x minus 2x minus 5. Now this is my group 1 and this is my group 2. So let me label them properly. Now, what is common for my group 1? The highest common factor is actually 3 with x. So it is 3x. I'm going to divide the two terms here in my group 1 by 3x. When 3x is divided into 6x to the second, you could see 6 is divided by 3, we get 2. When x goes into x squared, we get x. When 3x goes into 15x, we get 5. So we're left with 5 here. If you take a look at this, it's almost like this. It simply means then that I'm going to use 1, but I have to use a negative 1 so that when I divide this negative, I'll get a positive. And I'm only doing it because these are all positives here. So I know that I need positive 2x and positive 5. So when negative 2x is divided by negative 1, we get positive 2x. When negative 5 is divided by negative 1, we get plus 5. If you take a look now, the two brackets are identical. Because they are identical, I can now write back one of these brackets, which is 2x plus 5. And in the other bracket, I'm going to put 3x and then negative 1. And we're done there. Okay? So that is done. We're going to look at the last two examples. And it's going to be how to factor the difference of 2 squares. So first, so this is our 9th problem here. So this is x squared minus 1. Now, this is a special case. So let me list my square numbers first. So we have 1, 4, 9, 16, 25, 36, 49. You should see the pattern and it goes on to infinity. So in that pattern, those are some of the square numbers that you'll see appearing in these sort of questions. What are square terms? Square terms would be a square number attached. For example, a square number 1 attached to a square variable. All right. Remember, 1 is a square number. So x squared really means 1x squared. So we could have a 4x squared, we could have a 25x squared, and so on. To be honest, as long as you have an even power on your variable, it is a square term. So let us take this apart. How do you solve these problems? It's kind of very simple. All we're going to do is to take the square root of these, meaning what is the square root of x? X is coming from x squared. 1 is coming from 1 squared. There's a difference between them. It is called the difference of 2 squared because we are subtracting 2 square things. So the square root comes here. So the x was first. So we have an x, then 1. You repeat this, x, then 1. Then you put a plus and a minus. Or you could have put, so I want people to understand that you could have put the minus and then the plus. It doesn't matter. The main thing is that one would have a plus and the other would have a minus. So it's the square root, and we have to put them in the right order. Because the variable x was first, that's why these came first. And just that the number came after, that's why the number is after. Let's take a look at another problem. So let us say that we have the 10th problem here. We're looking at 25 minus 9y squared. Okay, you could see that 25 is a square number and 9y squared. The 9 is square and the y is square. So we definitely have the difference. The difference means we are subtracting two square things. So what would be the square root of this idea? The square root of the 25 is 5. So basically it's coming from 5 squared. What's the square root of the 9y squared? It's coming from 3y squared. And then this was between them. So that's where it originated from. So we want to be able to see that. And then we open two brackets. You're going to put the terms as they come. So we're going to have the 5, then the 3y. We have the 5, then the 3y. Again, you could put a plus, then a minus, or a minus, and a plus. There it is. That's all you need to know on factorization. See you next time. I trust that this helped you out. Bye-bye.